Hey everyone, hope y'all are doing well today. Unfortunately, I cannot be with you, so as soon as your tears clear your eyes of that fact, you can watch this video. I am going to go a little faster than we usually would through it, but that is because you will be able to pause, rewind, ask questions to me via email or tomorrow, all that. So if it's going a little fast, just know that is intentional. It is so that you don't have to watch it hour-long video, but instead you can get the information and go back if you need to. So, we are going back into topic 3 first, which is just we're going to discuss some polynomial functions. Looking at what those are today, we're going to start with the graphing part and some of the behavior and features that happen when we graph polynomial functions. So, you will need your Desmos calculator for this. So if you don't have that open, you may want to pause the video and get it open. And now that you do have it, I'm going to go to Desmos, and is we want to create a table of values for this function right here. Now, one way you could do it is if you want to individually type all those in, x, figure out the output, that is possible, but that is going to take a long time. Instead, what I'm going to do is let me go over to Desmos. And I have already typed the function in, as you can see. And I do know we can see the function graphed here, but we're going to hold off on that and kind of look at some of the features that we can see in the table instead. So what I'm going to do, I can't exactly point on here because it's just, but I'm going to click this little gear in the right up here, and that will open up these options. And I want to select the table, and ta-da, boom, hey, it'll do the table for me. But you'll notice it does not start at -3, so I'm going to change that -2 to a -3. And if I just click enter, it'll allow me to add in a -2, and then down here I can put a 3, and hey, I have my table, and I'm going to transfer that information over to the paper, which if you need to pause a second to write that down, please do. I'm going to move on. So, I have this over here, and what we want to do is I want to just roughly sketch what this is going to look like. So to do that, I'm going to kind of look at some features of the table. So what I notice is this table is kind of doing something. From -3 to -2, it looks like our function's increasing. We go from -11.5 to +6. Another important thing there is we also cross the x-axis because we're going from a negative to a positive. That'll kind of help us get that as well. Now, from -2 to 0, we decrease. But notice we're not crossing the x-axis because all of our values are still positive. So we're still going to be above. Then it looks like we switch back to increasing, still remaining above the x-axis. And then finally at the end, we decrease again. And here we go from a positive to a negative, and we cross the x-axis. All of those facts are going to allow us to put our picture onto the thing. Another thing we can just see pretty easily here that I want to point out, we do know right there, 0, 2, that has to be the y-intercept. So I may even go ahead and put that. I'm going to go ahead and put that. That's always a good starting point. Now, polynomial functions can do a lot, so kind of stick with me here. So when I look at this area here, I know -3, let's see, we're at -11.5, so somewhere down here. And then at -2, I'm at 6. And somewhere along here, as well. So we are just going to kind of sketch that. So we're going to go, now I need to go up. Not have to be perfect. And then at 6, a little cleaner. I know we're going to kind of turn. So let's see, at -1 I should be. So somehow in here I'm doing something like looks like we're going to go back up to 4.5. And then at 2, we also have 6 again. But then we're going to go back. Assuming that, right? I'm just going to sketch that as best I can again. And it'll look something like that, which is good. And we can actually check ourselves there. Let's go back over to Desmos here. And ours isn't exactly perfect. It was just a rough sketch. But we do have the same idea as our graph. So as you can see, polynomial functions graph a little different and look a little different than anything you've seen before. But I want to point out a couple of little things on here that you may see. First of all, notice we have 2 maximums, or 2 high points. And these, since we have 2 of them, we call these local maximums. Meaning, in that area, if you're local to something, you're near it, right? It is a maximum. It's not the maximum of the whole thing because there's multiple, but it is just a local maximum. You there? We also have a local minimum. Meaning in that area, this is the minimum. It does also turn out that that is the absolute minimum, or no, excuse me, not the absolute minimum. These continue to the function going further. So while this is not the minimum point of the function, it is a local minimum. And then another thing you may see these called, these are also called term limits. Any minimum, maximum is going to be a turning point, meaning at that point, the function will turn. So, just kind of some things you can get from there. Let's see. The other thing I did want to review with this is kind of your end behavior of it. We'll put this down here. That's what we did on Tuesday. So, to actually get the end behavior, we're looking at this. You can also see it over here. So remember, we're thinking about the right-hand side. We're thinking about x approaches infinity, right? So let's say as x approaches infinity, so you kind of think, what does this function do? Going down. Well, the function approaches f of x negative. On the left-hand side, or on the negative end, you can see x approaches negative infinity. F of x also approaches infinity. So, all of that, there's a lot in there, but it's a good review of what we did. Really focus on what's going on in this. Be familiar with the vocabulary words. Everything else, I think you'll be good. You also could think about, and we kind of talked about it here, but kind of your intervals increasing and decreasing as well. But we'll get to that a little bit more in example 4. So, what I want you to do now is take a second to pause this and do the try it here. I will post this solution. It'll be on Canvas right under this. There'll be a document with this all filled out. So if you want to pause it, give it a try, go check yourself. That'd be great. Cool. Hope you did it right. Now we'll go to example 4. So I think this one will be, I think it's a little easier. It's kind of a, not necessarily a puzzle, a little bit of a puzzle, but basically it says, how can you sketch a graph of the polynomial function f in verbal description? So it gives us these 4 facts and says, based on these 4 facts, make a picture. So a lot of ways to do it. I just kind of go through and start thinking logically. All right, so f of x is positive on the interval. So positive means above the x-axis, right? my x-axis here. Let's see. So that means from negative infinity, so coming out this way, negative 4, here is going to be positive. And then also from negative 1, positive 4, everything is positive as well. So the important thing about that is it tells me where I'm crossing my x-axis. Okay? Because if I go from positive to negative, we have to cross the x-axis. So I'm going to go ahead and plot those x-intercepts. Those are going to be very useful. And then we can kind of think about that with this, where it gives us this negative, meaning below the x-axis. Going back, let's see, we have this up here is positive, and then somewhere over here is positive. But then it tells us from negative 4 to negative 1, so down in here is negative, and from 4 to infinity is also negative. So it should do something like this. So we're going to use these last two clues to help us. So we have it decreasing or going down until negative 2.67. So I'm going to kind of think about that. Basically what that's telling me is I'm going to come here, see about negative 2 1/3, maybe in here. I'm going to turn to start going back up. This section here is probably going to look exactly like what I have. I'm going to go ahead and put a little point there to kind of say that. So then it tells me from negative 267 to positive 2, so I'm turning from here to here, I'm increasing. So it's, and then I go up, and then somewhere in here, so what you see there is more or less what this function is going to look like. So, something to kind of point out, we have our two turning points, right? And we also have a turning point. And then we would also call this a local minimum. Because in that area it's a minimum. This is a local. Then you could also talk about the end behavior, any of that, So if we want to think this end, x goes to negative infinity, our function you can see is going. So function's going positive. And then on the other end, positive infinity, function negative, which actually could even more so tell us that we know our degree is going to have to be odd because we're going in odd. And even more than that, the leading coefficient would be negative because trending in that direction. So do the try it. Check yourself on Canvas. And once you're done with that, there is an assignment on Canvas for 3.1 and 3.2 practice. You should have enough information to get most of the way through that. You will see a couple of new things that we're going to do next week. So if you get there and you're totally lost, that's where you can stop, and we'll do it next week. Have a good day, and I'll see y'all next time.